Good morning, one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV62 Module 1 Lecture Series 1. The introduction. In that we are discussing about soil exploration for 6th semester students. So today's our discussion is Introduction, Object and Importance of Soil Exploration. So introduction. What is meant by soil exploration? It is the process of determination of the properties of soil by using field as well as laboratory test data is called as soil exploration. So you can see here in this typical sketch, so some people they are doing a geographic survey, some people they are using a terrain sampling rig, they are using ground penetration radars, they are using for collection of soil sample or the variation of soil profile. Slope stability there some people they are doing here, cone penetration test some people they are doing here, some sample collection by using rig they are drilling rig they are using here, and drainage characteristics they are calculating some people here, and GPR survey so some people they are doing here, so window sampling so some people they are using, some blasting technique they are adopting for taking the soil that is a soil or rock sample, micrographic survey they are doing, and sinkhole survey there some people they are doing, and drainage how the path of drainage they are doing, cavity studies they are doing here, and ancient main working they are doing some people here, how the ancient mains are there, how it is working they are doing here. So all these things comes under one nutshell is called as soil exploration. So even survey includes the soil exploration. So I can say in one word, it is a process of determination of the properties of soil using field as well as laboratory test data is called as soil exploration. So here you can see why they are doing the stability analysis to know the stability of the railway embankment slope soil. Why they are doing ground penetration radar to know the wave propagation when a train moves here. For that purpose they are doing. So wave propagation where it takes place inside the soil, and here they are making some borehole. Why they are doing? To collect the rock sample. So here they are doing some blasting. Why they are doing? So they are collecting the rock sample. So sinkhole study, that is there may be some holes are there that has been bridged by soil or some rock, that studies they are doing because to prevent the weak pockets of soil in the ground, and there may be some cavity over a period of time that cavity has closed and it form a number of layers, or when a flow of water in the ground or below the ground has eroded some soil here and that leads to a cavity. So then a survey has to be done, soil exploration survey, to find what type of soil get eroded or what may be the type of soil here, so that we can expect future erosion below the hard bearing strata. For that we require soil exploration. And drainage characteristics, if it is a pure clayey soil, the drainage characteristics are very good. If it is a very poor, if it is a sandy soil, the drainage characteristics are very good. If it is a C5 soil, the drainage characteristics are in between them. For that we have to know the drainage characteristics. For that we have to do soil exploration. So if a deep variation of strata, that is if ancient main works are there, if any ancient variations or deep pile foundation we have to do, then obviously a rig bores are to be used. So for that soil exploration is required for collection of soil sample. So if you want to do a DCPT cone test, dynamic cone penetration test, static cone penetration test, all this test is to collect the soil sample. For that soil exploration is required. So these topographical survey, terrain survey, these are all peripheral survey for soil exploration, whereas these surveys what we are doing in detail is the subsurface soil exploration. Okay, so this is about soil exploration. Now you may ask a question, students, why we need soil exploration? What happens if I don't do soil exploration? So let us see a beautiful leaning tower of Pisa. So you can see here this tower has leaned by an angle 4 degree with respect to vertical. So when the bell tower, this is the bell tower, when the bell tower is yet to construct, and later on so many geotechnical engineers have done lot of struggle to restore this structure in the vertical direction. This is actual vertically it should be. This has leaning has taken place with respect to central imaginary axis and existing axis. This angle is 4 degree. So why so many researchers, geotechnical engineers, earthquake engineers throughout the world, so they are done a camp here years together, not 1 year, 2 year, 50 years, 100 years together, and they have done a soil investigation, subsoil exploration, and finally they come to a conclusion that because the soil strata is so erratic, that is a minute variation has made as the properties of soil itself will be different. So finally they come to a conclusion that this side soil, whatever the walls are there, this side soil is a rocky strata, whereas this side soil is a soft clay strata. Students, you can imagine in a small diameter of that leaning tower of Pisa. So within the diameter you have two different zones. One is a rocky strata zone, another one is a soft soil strata zone. Why this has happened? Because at the time of construction they are least bothered about soil investigation. As a result of it, so when they started constructing, when load bearing capacity of the soil is less compared to the load bearing capacity of this soil, obviously the settlement of the soil has taken place, which leads to the tilting. Fortunately, some lead shots has used so many techniques as the micronization of tiles and stabilization, chemical stabilization, everything is done. Finally, there are some lead shards they are used, and they are placed that lead shards are here, so that this side further tilting has some extent they are prevented. So on the day of construction, if they are done examining the subsoil behavior, probably this type of structure may not have existed at all in the world. So this is purely because of the failure of subsoil exploration. Now you can ask a question yourself, is soil exploration is required? Coming to the next example, you can see there is a platform here. So by seeing the traditional dress here, you can come to know that this is in India only. So this is the platform, railway platform in North India, and this is railway track, and people are waiting for train. So you can see the crowd, people are waiting for train. All of a sudden there is a landslide has taken place, and very close to this failure structure, so there is a houses are there. Why it has happened? Because so here the retaining wall is not designed properly. Designed properly means what? They are not considered cohesion and angle of internal friction into consideration when they are designing the retaining wall. As a result of which, the load from these buildings are heavy. You can see there is a policeman is standing here. Workers are doing evacuation work by preventing further sliding. They are inserting some railway I-section girders here. So it is a live example. Girders you can see here, because during heavy rain, water percolated, pore water pressure increase. This retaining wall is not designed for that one. So there is a caving out of the soil has taken place at the bottom. Top you can see this is remained as it is. Bottom caving out has taken place. This has purely because this retaining wall is not anchored properly into the ground. Who has to do? So it has to be done by structural engineers by taking the input data of a geotechnical engineer. That means if the geotechnical engineers has not done proper soil exploration, simply by assuming some C5 value, if they have done it, then you can expect this type of failure. By seeing all these things that Tulsi Katte and all, you can come to know that this has happened in India only. Okay. So now you can ask yourself, because of lack of soil exploration and design has ended with a disaster. Okay, so now you can question yourself, what is the object of soil exploration? The object of soil exploration is, so we can say that then to determine the nature of the soil deposit. Second one, to determine the depth and thickness of the varying soil strata and extent of the horizontal variation of the soil strata. You see the leaning tower of Pisa, within the diameter variation was there very high. You can see the retaining wall failure. So along a length the failure is very high. For example, if you see here, there is no failure here, there is a failure here. So the variation of soil here and here are different. So the extent of horizontal variation you have to determine. Location of groundwater table and its fluctuation has to be examined properly. Otherwise, water table will reduce the bearing capacity to 30 to 50%. And obtain the soil and rank sample for various strata for various soil investigation purpose, and determination of engineering properties of the soil, right, of rock that is affect the performance of the structure. So for doing that we require soil exploration and determination of in situ properties and field test, as I shown in the first slide. So the rigs we are using, penetrometers we are using, radars we are using, that is drainage assemblies we are using, blasting technique we are using, caving technique we are using. So what type of equipment and what type of instrument used for a particular soil strata is to be determined based on initial soil exploration analysis. So these are all the object of soil exploration. The overall object of soil exploration is a right instrument should be used in a right place so that we will get a exact soil behavior, so that we can construct a structure which will not subjected to this type of end results. It may be a failure of foundation of a retaining wall, or it may be tilting of a structure. So I can say the soil exploration may be needed not only for the design and construction of a new structure, but also for deciding upon the remedial measures for the structure show a sign of distress after construction. You can see there is a sign of distress. Definitely there is a sign of distress here. So after construction. So the site investigation refer to the procedure of determining the surface and subsurface conditions in an area of proposed construction. So it depends on two things in general and three things in particular. So one is nature of the project, second one is location of the project, and construction of that is the reserve for amount for soil investigation. For example, nature of the project means if you are doing for a Sriharikota launching pad, then cost is not a matter, the project is a matter, so you have to do very detailed exploration. On the other hand, you are constructing a low cost house in Sriharikota, then your cost of a project plays a vital role rather than the type of the ground. Second one is location of the project, where the project is located, whether the project is located in Gujarat, whether the project is located in Karnataka, whether the project is located in Gujarat. For small project, detailed investigation is to be done with respect to earthquake analysis, otherwise the structure will failure take place. Whether same project, if it is there in the Karnataka or Bengaluru, then you need not necessarily to worry much about the particular that is quantity of work. That means you need not necessarily to do in detail that is exploration is required, because the soil is very hard. And next is what is the cost reserved for the project, that soil exploration. Suppose if a project is 100 crores, So then if you are spending 150 crores for soil exploration, means nobody will accept it. Then what is the upper capping limit? You should understand. Generally 1% of the total cost of the project will be allocated for soil exploration. Now we should understand what is meant by significant depth of soil exploration. So significant depth means what is the depth up to which we have to do soil exploration, whether I have to do 1 meter depth from natural ground level, 2 meter depth from natural ground level, or 10 meter depth or 100 meter depth from natural ground level, we have to do soil exploration. So that depending on the isobar. Isobar means a line joining point of equal stress is called an isobar. So we have to plot the isobar. In order to plot the isobar, you should know the width and the intensity of loading on the proposed foundation. If you know that one, if you plot the isobar, in that isobar point 1 times q, if you mark it, whatever depth you will get it, up to that depth soil exploration you have to do it, because up to this depth the load intensity q will have an influence on the soil strata. Beyond that depth there is no influence on the soil strata. So you can see here 0.8 times q. So up to here, if B is a width, q is intensity of loading, and 0.6, 0.4, 0.3, 0.2 and 0.1 times q will have a maximum, that is a spread over limit. So up to which the whatever soil is there, that will be subjected to distress. Beyond that depth, the soil is free from this applied load q. So generally 1.5 to 2 times B will be taken as significant depth of soil exploration. Students, have you understood? Okay, fine. So next is coming to the MCQ questions. The process of determination of properties of the soil using field as well as laboratory test data is called as soil exploration. Option A is true, option B is false, option A it is true. The primary object of soil exploration are determination of nature of the deposit of soil. Option A is true, option B is false, option A it is true. The determination of depth and thickness of various soil strata and their extent in a horizontal direction, so is called soil exploration. Yes, it is incomplete statement, therefore option B it is false. Not to locate the groundwater table and fluctuation of groundwater table is an object of soil exploration. No, it is false. The object of soil exploration is to obtain the soil and rock sample from various strata. Option A it is true. The black tartan soil significant depth is up to 2.7 meter. So A, B is 3.7 meter, C is 4.7 meter, D is none of the above. So it is 3.7 meter below the ground level. Option B. The depth of investigation depending on nature of the project, location of the project. So both are correct, therefore option A is true. Usually the construction of a thorough investigation and exploration program will be less than 1% of the total cost of the entire project. Option A is true, option B is false, option A it is true. Usually the construction of a medium project does not require soil investigation. It is not correct, because where it is there, whether it is there in the hard bearing strata, yes, soil investigation is not required. Over an experience, you can go ahead with SBC assumption. But small project in a complicated area, erratic soil deposit, earthquake prone deposit, you have to do soil exploration. Therefore, I strongly obstruct or reject this statement, and I can say that the answer is B. The statement is false. Next, question number 10. Usually the metropolitan residential project required soil investigation. Yes, as per the metropolitan guidelines like BBMP, MUDCO, or HUDCO, etc. So if a plan has to be approved, so a detailed plan and a soil investigation report, rainwater harvesting location identification is must. Therefore, the above statement is correct. The option is A and the answer is true. So for preparing this that is presentation for module 1 session 1, I referred following textbooks. and reference books. Sketches I am taken from Google search. I take this opportunity to wholeheartedly thank my senior officers of Department of Collegiate and Technical Education. Commissioners are the Joint Commissioner, the Director, Principal, everyone. They are given an opportunity for me to deliver lecture through LMS for entire government engineering colleges in Karnataka. I am grateful to them, and also I take this opportunity to wholeheartedly thank the student community for listening my lecture. I request students, please go through the LMS portal and study the material. So I uploaded MCQs, study material, presentation and video, and practice the MCQ question. If you have any doubt at any point of time in an academic aspect in my presentation, so you can feel free to ask in the next class. Thank you for attending the class. Thank you one and all.